So let us start discussing about classification of continuous time systems. The continuous time systems are classified based on their characteristics. Some of the popular classification of continuous time systems are static versus dynamic systems. Static versus dynamic systems. A CT system, which is represented by a mathematical representation of y of t is equal to transformation of x of t, which is called a CT system, is called memoryless system or static system if its output at any instant of time t depends on present input but not on the past or future inputs. For example, I have a system y of t whose output is represented by y of t, which is equal to a into x of t. I have another system in which the output is produced simply by a mathematical operation t into x of t plus 6 into x cube of t. In all these cases, the output depends on the present input. There are some other systems where the output is equal to x of t into x of t, but you can see that the next component is actually 3 times of x of t squared. So when t is equal to 1, it requires x of 1. When t is equal to 2, x of 4 is required. For example, at t is equal to 2 seconds, if we calculate the output, y of 2 is equal to 2 into x of 2 plus 3 into x of 4. Agreed? So y of 2 depends on x of 4. As far as y of 2 is concerned, this is called future input. Alright? Similarly, we have another system, y of t is equal to x of t plus 3 into x of t minus 2, where you can see that at t is equal to 2 seconds, the output y of 2 depends on x of 2 current input. Also, it depends on 3 into x of 2 minus 2, which is equal to x of 0. X of 2 depends on past input. As far as y of 2 is concerned, it is x of 0, past input. So such systems are called in the name of dynamic systems. Systems with memory, they are called as systems with memory. Another category of systems in the classification, there is one more category called time invariant or time variant systems. Very popular keyword. You have to classify the systems whether they are time variant or time invariant. A system is said to be time invariant, TIV, if its output input relationship characteristics does not change with respect to time. Such systems are called as time invariant system. Right? I'll mention about a system. If y of t, when it is applied through a transformation function system, it produces y of t. In another situation, if x of t minus m is applied through the same system, it produces y of t minus m. If input is delayed, output will also be delayed. time invariant or shift invariant systems if and only if the following conditions are satisfied. For every input along with every time shift, you can define this. I can illustrate it with the block diagram. We have a system, x of t is the input. Let me introduce the delay. Let me call this as delay element, which produces delayed input signal. This is called the input, whereas this is called delayed input, right? Now you can notice that if it is applied through a system, it produces, the system is represented by some transformation, isn't it? The system is characterized by transformation operation, which is supposed to produce, say for example, y1 of t. Let me record the response for the delayed input. I have another input, x of t. If the input is applied through the system, where the system is represented as t of transformation of something, which produces y of t. Let me call this as the response for the undelayed input. Undelayed input. If this output is delayed, you can notice the difference. In the first flow diagram, input is delayed and then it is applied through the system. Output is recorded. Now the input is directly applied through the system. Response is recorded. Now the response is delayed, so that now you get a response. It is called delayed response. Delayed response. Right? Now, if a system is said to be time invariant system, y1 of t must be equal to y2 of t. Let's check with an example. I have a system called y of t, which is equal to 2 into t into x of t. Let me take this block diagram. Let us apply the input. What is the input? X of t is the input. What should be the first step? First delay the input. Produce the delayed input. Let me call this as x of t minus m. If I apply through the system is supposed to produce an output and it is recorded. y1 of t is equal to 2 into t into, now it is not x of t, because of the delaying operation, it becomes 2t into x of t minus m. This is called response number 1 for delayed input. I have the second procedure. The input signal is taken and it is applied through the system. The system is supposed to produce an output. The output is called y of t. The output is, let me say, as per the relationship, it is simply 2t into x of t. If I delay this, now the blocks are swapped. Did you notice? If the output is delayed, you have a response which is called delayed response, which will be written as 2 into t minus m multiplied by x of t minus m. Whatever the t is available, it is delayed. T is and all replaced by t minus m. In the second procedure, delay is to be introduced wherever t comes. T will all be replaced by t minus m. Whereas in the previous case, only x of t is alone delayed. Can you see the difference? The first case, x of t is delayed and delayed input is ready, and the delayed input is applied through the system, the response is recorded. Whereas in the second case, input is applied through the system, response is recorded, and then the output is delayed. Wherever t comes, t will be replaced by t minus m. Do you find both of them are equal? Is y1 of t equal to y2 of t? No. Then you can say that the system is time variant system. It is called time variant system. Let me show you one more example to you. I have a system, x of y of t is equal to x of t into sine of 20 pi t. I take the input signal x of t, I apply through a delay. Let me call this as delay element. The input is delayed. Now you can say that the input is delayed by m units. Now it is applied through the system. The system is called a transformation of something. So it produces the response is recorded. What should be the response? Wherever x of t is available, that alone be replaced by x of t minus m. Remaining all other locations will remain the same. It is recorded. Now I'll go to the next one. The next procedure, second step. Now I take the x of t, I apply through the system produces an output. Output is simply y of t, which is equal to x of t multiplied by, as per the equation, it will be the simple duplication of the equation given in the problem. But what should you do? The second step, you must apply delay operation. The delay will produce delayed response, so it will become y2 of t. Wherever t comes, it will be replaced by t minus m into sine of 20 pi into t minus m. T is and all Wherever t is available, it is replaced by t minus m. Wherever x of t is available, it is replaced by x of t minus m. If both are equal, both the responses are equal. Unfortunately, in this case, both the responses are not equal. So I can say that the system is time variant system. I'll show you one more example to you. One more example to you. Any system, I have a system y of t which is equal to x of t plus c. As per the first step, x of t is taken and applied through a delay operation. The delay produces x of t minus m. Now you can say x of t is alone replaced by x of t minus m. So when I apply through the system transformation of something, it produces y1 of t. The response is recorded. Wherever you get x of t, it is replaced by x of t minus m. Plus c was already available. It is not disturbed. The response is recorded. Now I take another system where x of t is applied through the system transformation of something. It produces an output y of t which is equal to x of t plus c. Now if I apply through a delay operation, you can notice that y2 of t, wherever t comes, t will be replaced. Unfortunately, here t appears only once, that too inside x of t. So what you are obtaining is a delayed response. In this case, y1 of t is equal to y1 of t is equal to y2 of t. So you can say that the system is time invariant system. Clear? Thank you.